Hello all, welcome back to Data Science Brain. In this video, we will be using computer vision to track the hand gestures, the hand landmarks, and use that to increase and decrease the brightness and volume of our system. As you can see in the right corner, we are increasing and decreasing the brightness and the volume of our system using hand movements. Okay, so that's what we are going to do today. So let's get started. Okay, so I will be using Jupyter Notebook, Jupyter Lab for this project. Okay, so it is better for, because it is better for explaining the code. Okay, so uh, just like our previous video, we will start by importing the necessary libraries. If you haven't already installed computer vision, CV2, OpenCV2, you have to install it using pip install. Okay, also numpy as well. If you haven't installed, you have to install this. Okay, so this might probably be pre-installed if you have already installed Anaconda in your system. Otherwise, you can install that. Okay, that will install all the basic libraries for machine learning. Okay, Anaconda. So we have imported CV2 and NumPy. Now we'll write a function def main, and we will call that function. So this is basically to ensure that this function is not called, this function is not run if and only if this function will only run if and only if we run this particular file and not when we are importing this to any other file. Okay, so that's all what we are doing here. Okay, so inside this function, what do we do? Just like before, we will capture the video. So our intention is to capture the video, and in that video detect the two hands, and from both hands detect the thumb and the index finger. And then what? Then we need to identify the distance between the thumb and index finger, and as that distance increases or decreases, we need to adjust the volume and brightness. Okay, isn't it? So that's our plan. So that's what we need to do. So for that, first we need to capture the video. So we will say cv2 dot video capture, and just like before in the past video, we will pass in the camera number there. So let us just try to see if we were able to see this. Okay, so we'll put it in a try catch block, so that if any error occurs, we will catch that. So we will put this inside try, and we'll say while cap dot is open. So we are basically saying while the capturing frame is open, we will get two things. We'll get the frame and get a boolean value that represents whether or not we are successful in reading the frame. We'll say cap dot read. This will return read and frame, basically. And then we'll say if not read, basically if we haven't received any frame, we'll just break. Okay, otherwise we'll say frame is equal to no, otherwise we will say frame is equal to cv2 dot flip. So we have done this in the previous video as well. Why do we do that? Because we need to see this frame in a mirror way, right? So just to mirror this, so it will feel like we are looking in a mirror. Okay, otherwise it will look awkward. So that's the only reason why we are flipping the frame. Okay, so after we have flipped, let us just see it. We'll use cv2.imshow function, and we will give a name to the captured frame. We'll say frame, and we will pass in our frame. Okay, so this is used to show the video live. Okay, and again this is just something that we need to do in order to make sure that we press a key, it will close. Okay, so we are saying wait for 1 millisecond after each frame and get keyboard input, and if that keyboard input is equal to 27, which is the ASCII value for escape key, we will break. Okay, that's what we are saying here. And after that we will say finally, after all of this is over, what do we need to do? We need to release all the uh, captured videos, frames, and we will destroy all windows. Okay, destroy all windows. Okay, destroy all the windows that is there. Okay, so that's what we do. All right, so now let us try and run this and see if everything works. Okay, now it will take some time to run. Um, okay, as you can see the video here clearly, and if I press escape, it will turn off. Okay, so that part is over. So we are able to get the video. So now what do we need to do? So we got the video. Now we need to recognize the hands, isn't it? We recognize the not just the hands but the fingers, isn't it? So for that we will use a library called MediaPipe. Okay, so this is the MediaPipe library, and this especially the hands module from MediaPipe library. Okay, so it's basically a machine learning model that is trained to detect the landmarks in hand. Okay, so we can see these are the landmarks in hands. Like, there are 21 landmarks they are able to mark correctly, which include the bottom of the palm, all the landmarks, all the knuckles and everything in the thumb, index finger, all the fingers. Okay, so as per our like, so what do we need is these two fingers, isn't it? The thumb, the 4 and 8, the thumb and the index finger tip. So we only need these two landmark, 4 and 8. Okay, and we will get the distance from this 4 and 8, and we will use that to increase and decrease brightness. Okay, so this is the module that we'll be using. This is the machine learning model that we will be using to get those landmarks. Okay, so let us import that. So you need to install this. Okay, you need to pip install MediaPipe before importing. So I have already installed, so I won't go through that. MediaPipe as MB, not NB, MB. Okay, so we will import MediaPipe as MB, and okay, and we need to set up this. Okay, so we need to do some setups here. So let us say, okay, setting up the model. Okay, setting up the hands model. Okay, so we need to set up the hands model. So we will say MediaPipe hands is equal to MB dot solutions. So that's the model. Okay, MB dot solutions dot hands, that is the machine learning model. Okay, solutions hand landmark. Okay, so MB dot solutions, where is it? Okay, solutions dot hands. So we get the hands module, and we will make a model. We will customize the model. So we'll say hands is equal to MB hands dot hands, and we will adjust some parameters. We will say static. So what are the parameters here? So we can see the parameters here that we can pass in. The static image mode, which basically says whether we need to detect an image or a video. So in this particular case, we need to detect video, right? Live frame. So we will put that as false. So we will copy this and put that is equal to false. False should be in capital letter. And then what? Then maximum number of hands. So we need to detect 2 hands, isn't it? So we have 2 things to control, brightness and volume. For that we need to detect 2 hands. So we will say maximum number of hands is equal to 2. Then what? Then the model complexity. The complexity of the hand landmark model. So this will improve the accuracy if we put this to 1. Okay. If it has 2 values, 0 and 1. So 1 will give higher accuracy. Okay. So we'll put that to 1. And then min detection confidence. Okay, so if this value is above, or above this threshold, only then it will consider it as a detection. Okay, so it will only then consider it as a landmark. Landmark basically means those points. Okay, these are the each of these points are the landmarks. Okay, so these points, 21 points, are the landmarks. So we are saying only if you are 75% sure that it is a landmark, take it as a landmark. Okay, and that's that. And then what? Then mean tracking confidence. Okay, so whether, when we move our hand and everything, it will track it. Okay, so that too we will put it as 75% confident. Only if you're 75% more confident, then only track that. Okay, so mean tracking and mean detection confidence, we are setting it as 75%. Okay, so 0.75 probability. Okay, So we have set up our hands model for detecting or let's say like recognizing the landmarks, basically the points in our hands. Okay. Now we will also get a get something called as drawing utilities for drawing for drawing the landmarks in our hands. Okay. So we'll say draw is equal to mb dot solutions dot drawing utils. Okay. So this will be used to draw all those landmarks, beautiful landmarks that we can see here. Okay. Like this. Okay. Yeah. And so now we have received all those things. So now let us see what we can get from that model. Okay. So we have the frame. So now before we pass in that frame directly, we need to convert it to RGB. Okay. So we know that from OpenCV everything is read in as BGR. Okay. So we need to convert that to RGB, red, green and blue channels. Then, or because MediaPipe expect it as RGB format. Okay. So we'll say CV2 dot, you know this from the previous video, BGR to RGB, where we have converted a BGR to HSV. Okay. So this is the function we use to convert RGB to BGR. So we have received the frame. We have got the frame in RGB format, and we will say we will process it. Okay. We will use the hands model that we have created to process it. We'll say processed is equal to our model, our hands model dot what process, and we will pass in this frame. Okay. So this will process the frame and detect the hands, everything. Okay. So this will detect the multiple hands and all the landmarks. Okay. So this object will now contain all the hands, all the landmarks. Okay. All the landmarks from both the hands. So let us print that and find out. Okay. Let us print that and find out what we have in there. Okay. So let us run all of this again. Okay. So we are getting the output, but we are not able to interpret anything from this. So let us check this. Let us check the output. Okay, so these are the output: multi-hand landmarks, multi-hand world landmarks, and multi-handness. And this is what we need: multi-hand landmarks. Okay, so this object will contain this multi-hand landmarks. Okay, basically the points in multiple hands, points in both hands. So let us print that and find it. Okay, so let us again run the code. It's running now. So yeah, as you can see, it is now printing all the landmarks that it is detecting from both the hands. Okay, you can see the xy coordinate and z coordinate. Z coordinates basically says the depth. Okay, and as we can see, the x and y coordinate values ranges between 0 and 1, right? So yes, we have received 21. So this will be returning 21 per hand per frame. Okay, so there will be total of 42 per frame. Okay, so 42 landmarks per frame. Okay, so in this format, the xy coordinates are of no use to us, isn't it? So we will deal with that later. Just keep that in mind. Okay. So we were able to get all the landmarks from all the frames. Okay. So this is how it get returned. Okay. From both hands, we will get landmark objects 21 per frame. Okay. So that's what inside that. So now since we have gotten this, we need to divide it into left landmark and right landmark, isn't it? So we have got everything together. So we need to split it into left hand landmarks and right hand landmarks. And also we need to draw it, isn't it? In order to see it. So for that, only then we can use both the hands to adjust the brightness and volume, right? So we will say left landmarks mark list, left landmark list, and right landmark list is equal to left and landmark again. We will write a function. Okay, get left right landmarks, and to this function we will pass in the frame so that we can draw on the frame, and we will pass in the processed frame, I mean processed object which contains the landmarks that is found in the frame, and we will also pass in the draw object, that will help us to draw the landmarks in the hands, and it will also pass in the hands model. Okay, so let us write that function. Okay, so let us say def all these things, and we'll just use this. Okay, and it so now we will create two list left, let's say left landmarks list. Let us say it is, let us put that to empty. So similarly we'll create a right landmarks list, because these are the two things that we need to return, right? So we will create two lists for that. So this list will contain the index and thumb for left hand and index and thumb for right hand. Okay, that top tip of the index and thumb. Okay, so we will say if this processed contains two hands, so if it contains multi hand landmarks, if it contains that object which contains the landmarks from multiple hands, then we'll say for hand landmark, hand lm hand landmark in this process dot landmarks. So we'll loop through all the landmarks. We'll say we'll get the index. So this will be two things. Okay, so this will be left hand, right hand. Okay, so hand lm will be having like array of either left hand landmarks or right hand landmarks. Okay, so we will loop through those as well. Okay, so this will hand lm will be having values, landmarks for either left hand or right hand. Okay, so we need to loop through that as well. So we'll say index and found landmark in enumerate handle m dot landmark. Okay, so we are basically enumerating landmark, isn't it? Okay, we are basically getting all the landmarks in either left or right hand. Okay, and this index will be ranging from 0 to 21. Okay, so 0 to 21 are the there are 21 landmarks. Okay, so this will be ranging from 0 to 21. Okay, and handle m will be either left or right hand. Okay, so we will get all the we will loop through all the landmarks in either hands. And now that problem we have told before, that is the distance, not the distance, the xy coordinates are ranging between values 0 and 1. Okay, so in order to get the actual xy coordinate, we need to multiply this with the actual width and height of the image. Okay, so only then we will be able to get the actual x and y coordinate of that particular landmark. Okay, again I am saying a landmark means these points. Okay, any of these points. Okay, so this point will be represented as x and y coordinate. Okay, x and y point, and the value is represented at 0, as a value that ranges from 0 and 1 here. So we need to multiply this with the actual width and height to get the actual position, actual xy coordinate of that landmark in the frame. Okay, in the frame. Okay, so that's what we are going to do next. X comma y is equal to, we'll say int of the found landmarks x value multiplied by the okay, so we need to get the width and height first. Okay, so we'll say the height comma width comma the RGB channels, we will get all those from frame dot shape. Okay, this is the function that is used to get the shape of a data frame. Okay, shape of a data type. Okay, so shape of an array. Okay, so height and width. Okay, so we'll get the height, width and the three channels. We only need the height and width, so we will multiply x with the width to get the actual x value, actual x coordinate, and we will multiply, similarly we will multiply y with height to get the actual y coordinate of that particular landmark we have just detected. Okay, identified. Okay, so we will say if So we only need the two landmarks, right? I mean the two landmarks which are 4 and 8. We only need 4 and 8, isn't it? The tip of the index and tip of the thumb. So this will have all the landmarks. So among them, if the index is equal to 4, or if the index is equal to 8, then only we need it. Then only we need it. Otherwise we don't need it. Okay, so we are saying if this is equal to 4 or 8, we will store it inside landmark. Okay, we are saying it's a landmark, and we are storing the index as well as the xy coordinate of that particular landmark. Okay, either the index or the thumb, the tip of the index or the thumb. Now we are saying we have created, so now we need to append this to the left or right landmarks list, right? So for that we will say handle m, if handle m equal to process dot multi landmarks of 0. As I have said, this will be having two list of arrays, I mean list of objects, either the left hand landmarks or the right hand landmarks. 0 represents the left hand landmarks and 1 represents the left right hand landmarks. Okay, so if handle m is left hand landmarks, we will push that landmark into left hand landmarks list. Okay, not push, append. Push is in JavaScript. So we will append this into left hand landmarks. Otherwise we will say elif. Okay, elif it is 1, elif it is 1, we will push it into right landmarks list. Okay, and we also need to visualize this, isn't it? We also need to see this beautiful landmarks being detected. For that we have this thing here, isn't it? So we will draw landmarks. Where do we draw it? We will draw it in the frame. And what do we want to draw? We want to draw the landmarks, and mb hands the hands dot hand connections. We'll get all the hand connections and draw it. Okay, so this line of code will draw all the hand connections and landmarks and everything. Okay, so that's what we are doing here. Okay, so after that we need to return this, isn't it? So we will say, I hope it is intended correctly. Okay, no, we'll say return. So we need to return these two things, isn't it? Left hand landmarks list and right hand landmarks list. Okay, so this will do that. Now let us again run this and see if we are able to see our landmarks drawn, because we have written the code for that. Okay, it will take some time. So unfortunately we are still not able to see that, I guess. Okay, I have found the problem. I haven't put this two things here, so we need to add the columns there. Now let us run this again and see if we are encountering any other issues. There might be some issues. It is running now. Okay, float object cannot be interpreted as, oh of course. Okay, we have done a terrible error here. So it should be like this. Now let us try it again. It is running now. Another error. Hands has no object, no attribute hand. Oh, sections. Oh god, spelling mistakes. Okay, connections now. Okay, I hope that's the last of the errors, because it has come down here, so the loop will return now, hopefully. Oh, another error. Oh, it doesn't have hand connections, huh? Okay, so yeah, obviously we have made an error here, I think. Yeah, okay, so we have passed in our model there. So instead we should pass in this here. So this is the one that has this um, hand connections. So let us run this again. This will surely, most likely, will work now. And yes, as you can see, it is detecting the landmarks in our hands correctly. And it is detecting all the 21 landmark points. I mean, complete 42 for both hands. Now we need to calculate the distance between this point and this point and this point and this point. And whenever I am increasing or decreasing that distance, I need to increase and decrease the brightness and the volume levels. Okay, so that's what we need to do. So this is xy coordinate and this is an xy coordinate. So we need to calculate this distance. So if you learn max, we can calculate the distance between two coordinate points using Euclidean distance, isn't it? So we'll calculate the distance between this point and this point using Euclidean distance, and we will use that distance to increase and decrease the brightness. Okay. So now let us get the since we have got the left landmarks and the right landmarks, let us get that distance. Okay, using this um, landmarks. Okay, so we will say if so since we have gotten this separate landmarks, we will use that. We'll say if left landmarks. Um, so what do we wanted to do if it was left hand? We need to increase the brightness, right? So we will get the distance for thumb and index for the left hand. Okay, we'll say left distance is equal to we'll write a function get distance that calculates the Euclidean distance. Left distance is equal to, I mean, get distance. We will pass in the frame and we will pass in left landmark list. Okay, so we will use those two things, and let us write the function here. Def get distance. Why am I doing this every time? Okay, get distance, and we will say so only if there are two values in this, we need to calculate this distance. Okay, because we need 2 points to calculate Euclidean distance. Okay, so if this is less than 2, we will simply return saying there is nothing, and otherwise we will get the points. We will get the so Euclidean distance calculation is something like this. We'll say Euclidean distance. Okay, so Euclidean distance we need 2 points, and let's say P and P1, P2, and Q1, Q2. Oh, this doesn't represent it correctly. So X1, X2, and Y. I mean X1, Y1, and X2, Y2. Okay. So to calculate this distance, this is the equation. Okay, root of X2 minus Y1 the whole square. This is actually wrong. X2 minus X1 the whole square plus Y2 minus Y1 the whole square. Okay, so that is the equation. Okay, X2 minus X1 the whole square plus Y2 minus Y1 the whole square and the root of that. Okay, so this one is correct. I will zoom in. So X2 minus X1 the this is wrong again and again and again. Okay, we have gotten one correct. X2 minus X1 the whole square plus Y2 minus Y1 the whole square and the root of that. That will give us the Euclidean distance between two landmarks. Okay, two XY coordinates. So we will get those 2 points first, X1, Y1, and we also need X2, Y2. We need both of these. And from where do we get it? From the landmarks list, isn't it? From the left landmark list, and 0, 1, this will be what? This will be either thumb or index, and the 1 means the x value, and the 2 will mean the y value. Okay, so that's that. And similarly, what do we need? Similarly, we need um, the thumb, I mean the other finger as well. Similarly, we need the other finger. So we will say 1 here and 1, 2. Okay, So this will give us the x1 y1 and x2 y2 values. Okay. So after we got that, we will just represent it. We'll just draw some circle and two circles each for the tip of each fingers on the frame, and also a line to represent the distance between them. Okay, so that we can see it. So for x1 y1 with this 7 as radius, and color will be 0 to 55, it will be a green color, and cv2 dot filled, obviously. We will do the same for x2 y2, and we will draw a line. Okay, we'll draw cv2 dot line, actually line, and we'll pass in the frame. And how do we want to draw the line? We need to draw the line between these two coordinates, isn't it? We need to draw the line between these two coordinates. Oh no, x1 y1 comma x2 y2. Okay, yeah, again we need to use the same color, green color, and we will need 3 as the thickness. Okay, so this will draw the line. Now the important thing, we need to calculate the distance, Euclidean distance. Now for that we will import another library. Okay, so we will import a library from math. So from math, import hypot. Okay, so this will calculate the Euclidean distance for us. Let us run that. Okay, so this will be used to calculate the Euclidean distance. Okay, so we'll use we'll say hypot. We'll say hypot, and we will pass in x2 minus x1 and y2 minus y1. Okay, so this will calculate the Euclidean distance. Okay, and after we have calculated that, we need to return it. We will return L. Okay, so from here we will get the distance between those two, index and the other fingers. So let us just run to make sure that everything is working correctly before proceeding. So this will return the length, the distance between yeah, of course we have entered landmark list is not defined. What do you mean that? Of course, left landmark list. Yeah, that's why I have run that. Okay, we are probably going to encounter some errors, I know that. Okay, so this will return the distance between the thumb and the index finger for the particular hand. Okay, and since here we are trying to find the distance between the thumb and the index finger for the left hand. Again, what? Landmark list is not defined. What do you mean by that? Oh, this one more was there. Okay, so here we are returning the left hand's thumb and index, distance between thumb and index. Okay, so as you can see, our code is working perfectly. We are able to detect the points between the thumb and the index finger, and we are able to draw that line. So we will be able to get this distance. Okay, so we are actually getting this distance. Okay, so it's working perfectly. So right now we are only taking the left hand, so that's the reason why it is not able to detect both hands at the same time. But anyway, we have done this. We are able to draw the lines there. So we are able to pick up the length. Okay, so now let us proceed with increasing the brightness, and then we will move on to editing both the hands at the same time, and change both the volume and the brightness. Okay, so let us get to that. So for increasing the brightness, right now what do we have? We have the left distance, isn't it? The distance between the thumb and the index finger of left hand. So that's what we have, right? So using this, how can we increase the brightness? So for that, what do we need? First we need to map this distance. So this distance will be having any value, right? It can be ranging from 0 to 255 or any value, right? So we need to map that value, that distance, to a value that ranges between 0 to 100, isn't it? So only then we can adjust the percentage, isn't it? So we need to map this left distance, this distance from thumb and index to a value um, between 0 and 100. So that's what we are going to do. We are saying brightness level is equal to NB. We will use a function called interpolate. Okay, interpolate. So interpolate basically takes in our value, and we will pass in an array of values that we think will be the value that will come in this left distance. We'll say, left distance can take in values that are between these range, and we are saying we need to convert that to this range. Okay, so what happens here is that if left distance is equal to 50 or less than 50, it will map to 0. If it is greater than 220 or equal to 220, it will map to 100. And whatever value that comes between 50 and 220, it will map to a value between 0 and 100. Okay. So that's all this is doing. We're taking left distance and mapping it to a value between 0 and 100. Okay. Because that's what we need. We need a percentage to change the brightness. Now, one more thing that I have made here is that, giving this as left landmark list name. Okay. So this will just be landmark list. Okay. Because we are passing in um, we are also passing in right landmark list here. Okay, so this should the naming should be landmark list. Okay, we are using the same function for calculating the distance between thumb and index for the right hand as well. Okay, all right, so we have the brightness level now we need. So now we need another package for increasing the brightness. So this package name is um, screen brightness control. Okay, so screen bright bright brightness control. If you haven't installed this, you have to install this using pip install. Okay, pip install screen brightness control. Okay, as s not bc sbc. Okay, so we are importing screen brightness control as sbc. Now it is simple. Now we have done everything. Okay, now we just need to call that sbc, and it has a function called set brightness. Okay, simple, very simple, set brightness, and we have already calculated the brightness level, and we will pass in that to this, and this will set the brightness. Okay, now let us test it and see. So let us run the code, and it will take some time, and let us keep this as well. Okay, I think we have encountered an error. Numpy has no oh numpy has no function named interpolate. Okay, so we made a mistake. It is not interpolate, it is interp. Okay, I mean, it's the same thing. I just spelled it out and written out the same way. It is interp. Okay, basically it is interpolate. So let us run it again. It will take some time, and this time it should work. Okay, it will work. So we have here. Okay, yes, we are successfully increasing. As you can see on the right side, we are successfully increasing and decreasing the brightness using our fingers. Okay, so yes, we are successful in doing that. Now we will move on to increasing the volume as well using our other hand. Okay, so we have done first part, we will move on to the second. Okay, I need to increase this before going. Okay, all right, now we will do the same for the right hand. Okay, so we will say elif, it's elif we have right landmark list, we have something in the right landmark, we will do the same, we will do right distance is equal to pass in the right landmark list, and instead of brightness level, what do we need? We need the volume level, isn't it? So that's what we need. So for that we need some other library as well. Okay, so this will take a little bit more. So let us type in some comments here. We are changing brightness. Okay, and let us do the same. Oh, same here, we are changing volume here. Okay, so we know that, for a brightness it is range between, I mean, it will range between 0 and 100. Okay, but the volume level can range between different values depending on your speaker, isn't it? So for that we need a min volume and max volume, right? So we'll say volume is equal to the same thing we will do, but we need a min volume and max volume. Okay, the same thing we will do. But we need to map it to a min volume and max volume. Okay, so for this, for getting the min volume and max volume, and also for setting the volume, we need a couple of libraries. Okay, so say there are a few things. You don't have to by heart this. You just need to watch whatever I am doing. I will explain some of these things, but mostly these are related to the system. Okay, so basically C types, com types, all these things are related to Windows, and Windows has been coded. Okay, so these are C++ libraries. Okay, so what we are doing is we are importing a library called Pico. So Pico is a library that will let us interact with the audio interface of our system. Okay, so we will be able to interact with the audio interface of our system using this Pico library. Okay, Pico library, and also this com types and all these libraries, C types, these three libraries will let us interact with the speakers and increase and decrease the volume and get the volume and all those things. Okay, so that is what we are going to do. You don't need to know exactly what we are doing here. We are just, I mean, this is not machine learning. This is just something that we have to do in order to control the volume of our speakers. Okay, so we will first get the devices. Okay, so your system will be having different audio devices, right? So we will use the audio utilities module from the Pico library to get speakers. Okay, so we will say get speakers, and so we will get the speakers using that, and then we need the only if we get the audio interface we can use its use its functions to increase decrease volume, to get the volume, all those things, right? So there is always an interface between a device and the OS, right? So the interface let us communicate with that with the hardware, right? So we will get the interface from our device. So we will say devices dot activate. So we are basically just connecting to the interface of our audio. Okay, so just type in whatever I am typing in here. We will pass in our audio endpoint volume.iid. We will say we need to select all the endpoints. Okay, so we need all the endpoints for our all the for our interface, and we will say volume is equal to cast. We will cast the interface, and also we will point to that. Okay, pointer. So I myself don't have 100% idea about how this is working. So this will basically let us control the interact with the audio devices using, through this interface. Okay, so that's what we are basically doing here. So we will get the volume range from this. Now that we have connected, we have access to the audio device through the interface, we will get the volume range so that we can get the min volume and max volume. So we will say volume dot get volume range. So we will get the volume range, and this will return us three values: min volume, max volume, and another value that we don't need. So we only need those two values. So we will get those two. Okay, so we have received the min volume and max volume. Okay, so and we will also later use this volume variable to set the volume as well. Okay, so we have received this min volume and max volume. Now we will pass that into this min volume and max volume. We will pass that in that. Okay, so and after that this will get the volume according to the left distance. Okay, actually right distance. Okay, so this will map the right distance to a value that is between the min volume and max volume. Okay, so now everything, the only thing that is left is setting. So we will use the same volume object that we have created before, that has access to the interface which will interact with the audio device, that will allow us access to these functions that will allow us to control those devices. Okay, so we will say set master volume level to wall. Okay, that's all we need to do. It will take in two parameters, one volume and that we will leave it as none. Okay, so this is all we need to do to set the volume. Okay, I know there are some confusions here, but you don't have to worry about any of these things. This is nothing related to machine learning. This just allows us to control your control the volume of the devices. This will just give us access to the interface that connects between the OS and the audio device. Okay, I think that is what this is doing. Okay, all right, so that's all. I hope this will work now. I think we have done everything. Now let us just run it and see. Okay, and one more thing, you have to install Pico if you haven't already. All the other two things comes pre-installed. Okay, so let us test now. All right, so we have this here. Yes, the brightness is working. So let us see if the other hand. Oh, there is some issues. It is not detecting both hands same time. Let us see what happens. Mm. Oh, okay. Sorry, I have put this elif. So if it's elif, then it will only check one of those. One of those. Okay. So let us run it again and see. So these are some mistakes that you will make while you are coding. Okay. So nothing to worry here. So yes, one hand is working. Hopefully, yes. Now we have both hands working perfectly. And as you can see on the right corner, we are controlling both things at the same time. Okay. Yes, we have done this and we are able to control our volume and the brightness of our system by using hand gestures. Okay. And it works perfectly well. Okay. It is so accurate. It is really, really accurate. Okay. So that's all about that. I hope you have enjoyed this video. And if you have any suggestions or if you need any additional explanation on any topics, comment it down below. And yeah, have fun with this project and you can explore this further. Maybe you can add some more gesture control by moving your hands or closing it or anything. You can do anything. Okay, there are 21 endpoints here, 21 landmarks here. Okay, you can have fun with this. Okay, so kindly like, subscribe to our YouTube channel and share this video with your friends. Okay, thank you.